So the first one that we're going to be looking at here, it's a very nice question. It comes from Mazawat Magudu, and it's an awesome question. It's question 3 from the March 2011 past paper. And then it reads as follows. 3.1 says, the first two terms of an infinite geometric sequence are 8 and 8 over the square root of 2. Prove without the use of a calculator that the sum of the series to infinity is 16 plus 8 square root 2. Okay, so there's a couple of very exciting things that you guys have to keep in mind. Of course, this is sequence and series, it's number patterns. It is definitely part of what is going to be examined. So remember, there are 3 patterns that you're going to have to worry about. You guys should know that there is a linear pattern, which is also known as an arithmetic pattern. That's a very, very exciting pattern. It is always in every exam that you guys are working with, okay? The second pattern that I want to draw your attention to is what we call a quadratic pattern. This is also another pattern that is definitely in all your exams. And the last pattern that you must worry about is what this question is based on, which is what we call an exponential pattern. It also has a name. An exponential pattern is also known as a geometric pattern. So these are the words that they use in the exams to try and guide you or just tell you what you're working with. Sometimes they may tell you, sometimes they may not tell you what type of a pattern you're working with. So for example, if they don't tell you that you are working with a linear pattern, how would you identify a linear pattern? A linear pattern will be something such as maybe 3 or 5 and then 7 and then 9. How do we see them? They all have a common difference. The difference between 3 and 5 is 2. The difference here is also 2. And the difference here is also 2. Once you start trying to find the difference between consecutive terms and you find some weird number that happens to be the same all the time, then it means that pattern is a linear pattern. Of course, in the linear pattern, we can ask you a couple of things. We are doing final touch-up, so it's much more important for us to just, enlighten you with a lot of things that are very important that are going to be in that exam. You might be asked about the general term. We know the formula for this is going to be a plus n minus 1 times d. We know if they talk about the sum, you'll use the Sn formula, which is n over 2 into 2a plus n minus 1 multiplied by d. When they talk terms, they will be talking about Tn, and if the examiner is talking about sums, you should think of the formula Sn. So it's always easy to identify what they're talking about, provided you are reading carefully through the love letters that the examiners always write for you. What is special about a quadratic pattern? Well, a quadratic pattern has a second common difference. An example of a pattern that is quadratic could be something like I'm thinking, let's just say, for example, if they give you 1 and then they give you 4 and then they give you 9 and then they give you 16 and so on and so on. The difference between 4 and 1 gives you 3. The difference between 9 and 4 gives you 5. And the difference between 16 and 9 gives you 7. You will notice that the first difference is not a common difference. So you try again to find the difference. You then get 2. If you try here to get the difference, you get 2. So in a quadratic pattern, you will obviously be quizzed on finding the general term of the quadratic pattern. We know the formula for that is Tn is an squared plus bn plus c. You will then be en route to try and find what is this a, what is b, and what is the value of c. How do you work those out? It's a very, very awesome idea. We always equate 2a to this the second difference. We always put 3a plus b to be equal to this, and we also say a plus b plus c is equal to that number there. That's how you are able to figure out what your a value is going to be and what your b value is going to be and what your c value is going to be. So if you are aware of this, the quadratic pattern shouldn't be a problem. Perhaps the only thing I might want to add on the story of a quadratic pattern is, I don't know if you guys noticed, if you go back to this quadratic pattern, let's just isolate it and talk about it before we answer this awesome question. We said the pattern is 1, 4, 9, and 16. The difference here gives you a 3, the difference here is a 5, and the difference here is simply going to be a 7. Now, I don't know if you guys have noticed that if you are dealing with a quadratic pattern, the first difference of a quadratic pattern is actually a linear pattern. So sometimes the examiner will be talking about a quadratic pattern. However, they examine you from the angle of its first difference, which happens to be a linear pattern. Just know that. Always be aware of these kinds of tricks that the examiners might introduce in the exams, that if I'm looking at a quadratic pattern, the first difference of a quadratic pattern forms an arithmetic pattern. So be aware of these. Those are the kinds of things that the examiner might be testing you with. They might use that angle to try and confuse you. Don't be confused. The other thing that I want to say about a quadratic pattern is be careful. A quadratic pattern is quadratic. Its general term is an squared plus bn plus c. If you had to draw this thing, you would get a parabola, depending on what your a value is. Obviously, if this is a positive value, you'd get a smiling parabola. If it is a negative, you then get a set face parabola. Why am I introducing this to you? Sometimes they ask you about the minimum value on a pattern, or they may ask you about a maximum value on a pattern. This is just as good as asking you for the turning point of the graph, because we know that the minimum point on a parabola or a quadratic function is found at the turning point, and its maximum likewise. You'll then use, like you guys know from functions, we say x is minus b over 2a if you are looking for the x coordinate or the turning point. But in this context, you wouldn't be obviously looking for x, you'll be looking for the position. So your variable changes from being an x and then it becomes an n. B is still B, A is still A. You can then find the position at which the minimum value is found or the maximum value is found, and then you can answer it from that perspective. So what I'm basically trying to emphasize here is, as you're working with quadratic patterns, you may get to questions that are a bit more challenging. If they are challenging, either they're quizzing you on a quadratic, but they're using the linear ideas on it, okay? Which is the first difference of a quadratic pattern. Secondly, they might be asking you on something that requires you to think about the graph graphically, the pattern graphically. Only then and only then can you be able to wisely come up with solutions of how to solve that problem. Beyond that, nothing is difficult. All right. Now, the one that we are working with that you guys sent to us is a geometric pattern. What is special about it? Well, a geometric pattern has a common ratio. Examples might include something such as 2, 4, maybe 8, and then 16, and then 32. The funny thing about this is some of you try to find a difference. You try to find the first difference, you get a 2. The second difference, you get a 4. The third difference, you get an 8. If you the difference gives you 16. Then you're like, okay, since the first difference is not common, this thing is not linear. Let me test for quadratic. If you try to test for quadratic, still you see that no, something is wrong here. I'm not getting something common. So once you start noticing that you're not getting a common thing here, we've got a problem. If we've got this kind of a problem, it means your thinking is not in the right direction. This is not linear. This is not quadratic. It's not linear. It's not quadratic. So if it's not linear and if it's not quadratic, it's definitely going to be an exponential pattern. So what are you going to do? You go back. You remove everything that you've done. Abandon mission. Abandon mission. Let's go back and see if we can think about it differently. So it means we're not adding anything here, but instead, what we are doing here, this number was actually, what is this? It's 16, yes. Okay, fine. And then this is 32. So we then look for the ratios. So you're looking for term 2 divided by term 1, term 3 divided by term 2. The ratios, that's what you're looking for. You divide here, you get 2. You divide here, you get 2. You divide here, you get 2. Therefore, we can clearly see that we are getting a common ratio. So this thing is definitely an exponential pattern or a geometric pattern. So these are the guidelines of what you need to look for when you're dealing with sequences and series. What I want to emphasize again, beyond just the numerical questions, examiners are out there to try and get your soul. So what they will do is they will think of anything that is weird and that looks scary. They might give you a staircase. They might even talk about anything, a tree that grows. First year it grows by this amount, second year it grows by this amount. The idea is you will identify that I'm now dealing with sequence and series. Let me try and look at what is going on, the English that is complicated there. Try to extract values there, numbers. Put the first number, try to see as this thing continues, what's the second number, what's the third number, what's the fourth number. You'll start noticing that the pattern emerges from there. Once you've got that pattern, you can then start working on it depending on whether it's linear or it's exponential or it's quadratic. And then they will ask you about terms and sum. If I say total, I'm talking about sum. But if I talk about a specific value, then I'm discussing terms. Once you can be able to differentiate those kinds of things, you guys are good to go. You will never have any problems and you'll be able to get the solutions without any flaws. Okay, so let me go to this question that you guys sent to us. It's an awesome question. There's a lot of formulas that you guys need to know that you are going to work with in this case. So we were told that this one is geometric. So that means we don't need to struggle about trying to figure out what type of a pattern you're working with. So we are told that the first two terms of a geometric sequence, the fact that they're saying it's geometric, we know that it's got a common ratio, okay? Right, the first term is apparently, according to this, 8. The second term is going to be 8 divided by the square root of 2, right? That's what I have so far. With term 1 and term 2, right, I can be able to work out the ratio by saying the ratio is obviously term 2 divided by term 1. Mathematically, it's 8 over root 2 divided by 8, which you can simplify to 8 over root 2 times 1 over 8. You do tip and times. So basically, according to what we are looking at here, 8 and 8 over root 2, if you divide them, term 2 divided by term 1, you will end up with a solution of 1 over the square root of 2 as your common ratio. Notice that my denominator is irrational. We'll get to rationalization when the time comes. But at the moment, we're interested in finding whatever they're asking. So what exactly are they asking? This is just a given information. What they're asking is they're asking us to find the sum of the infinite terms of this particular series. We are looking for the sum to infinity. Okay, so let's go and try to figure out how that is going to pan out. So the formula for sum to infinity is a divided by 1 minus r, and you know that the ratio needs to be a number between -1 and 1, which means it has to be 0 point something, okay? So what is my a value? We were told that these terms, the first one is 8 and the second one is 8 divided by the square root of 2. I've got the first two terms, guys. I only need to know what a is, and I also need to know what the r value is going to be. My a is 8. Be happy with that. 1 is a number, okay? The ratio, we just found that when you do 8 over root 2 divided by 8, you end up with an answer of 1 divided by the square root of 2, okay? Now, the examiner said without a calculator, so we have to demonstrate our algebraic skills here and prove to people that we watch Tenfold live, so we are able to add and divide fractions without a calculator. So what I'm going to do on the numerator, I'm keeping my 8. There's my 8. I'm changing the division line to a division sign, and on the numerator, I'm changing 1 to the square root of 2 divided by the square root of 2. Why? Because square root 2 over square root 2 is just simply 1, okay? Minus 1 over the square root of 2. Then the mathematical addition of fractions says if the denos are the same, if the denominators look the same, you can just pick 1, and then you just return the numerators exactly the way you see them. Pretty beautiful stuff, no complications. Then this is going to be 8, obviously. I'm going to apply the concept of tip and times in this case, okay? So what I'm going to simply do, I'm going to say, okay, times. On top, I'll put square root 2, okay? Yes, and then on the denominator, what I'm going to have is the square root of 2 minus 1, okay? Let's just see how far this is going to go. You multiply that stuff, you're going to get 8 square root 2 divided by the square root of 2 minus 1. We need to rationalize the denominator. How do you do rationalization? You multiply this by root 2 plus 1 over root 2 plus 1. You could have probably got here much quicker with a different idea, but there's nothing wrong with what we've done up to so far. Add the fractions and the denominators, you end up with what we're looking at, and then you apply your tip and times. You change division to multiplication, your fraction becomes upside down. You're looking at what we have now, so this guy times that is going to be 8 times 2, because root 2 times root 2 is simply 2. Okay, then this guy times that guy over there will just be plus, all right? 8 square root of 2 over. Now, root 2 minus 1 and root 2 plus 1 is dots. Difference of two squares. It's like a minus b times a plus b. That simplifies to the first thing squared minus the second thing squared, okay? So the first thing squared is root 2 squared, which gives you 2. The second thing squared is 1 squared, which is 1. 2 minus 1 is 1. On the numerator, the product of 8 and 2 is simply 16, and this leaves us with 8 square root of 2, and this is what the examiner wanted us to prove. Not complicated. If we say don't use a calculator, respect the instructions, you'll be penalized. If they say round off to 1 decimal place, do exactly what they're asking. Otherwise, they'll take marks away, because examiners are very sensitive people. They don't like people who don't listen to them. All right, let's move on to the second part of this awesome question. The second one says to us here, the following geometric series is given. So there's actually x equals 5 plus 15 plus 45 plus ... to 20 terms, okay? This is going to 20 terms, right? So let's try and reproduce that and talk about it. So we know that we are dealing with a pattern where they said x is 5, and they told you that it's geometric, so we're happy to see that. 15 plus 45 plus ... they say it goes to 20 terms, so it goes up to T20, all right? Now, the first question says we need to write down the series in sigma notation. Okay, how does sigma notation look? We need to just write this in sigma notation. That's what the examiner is asking here. This is pretty obvious and straightforward. There's no complication that you're going to actually encounter. So what I'm going to do is I'm going to put that Greek letter S. This is capital letter S for Greeks, in case you didn't know, which should be wrong by this time. You should be knowing what this is. Okay, so in sigma notation, you're just looking for three things. If I say convert something to sigma notation, you need something here, okay? You need something here, and you also need something here. So you're just looking for three things all the time, okay? So what do we have at the bottom? Let's start from the bottom. Start from the bottom to the top. I'm sure your life is actually supposed to progress like that. You start from nothing and then you increase to become something. Okay, starting from the bottom, you always put n as 1. If you have to write it in sigma notation, start from 1. You can obviously start anywhere, but for simplicity, always start at 1. All right, what you put on top is the total number of terms you're dealing with. So we're dealing with 20 terms. We're going to go from term 1 up to term 20, thanks to the information that was given to us. Now, what comes here is always the general term. The Tn is what you always put in there. They said this thing is geometric, so we know the general term for the geometric is ar to the power n minus 1. What is a? A is 5. What is r? R is the ratio. Term 2 divided by term 1. When you divide these terms, you get 3. When you divide these terms, you get 3. So we can clearly see that our ratio is 3 to the power n minus 1. Please don't embarrass us by multiplying 5 and 3 to get 15. This is a terrible thing to do. Don't do it. Abandon mission. This is not supposed to be done. The exponents are not the same. Those bases can't react with each other. What you can do is just leave it the way it is. There's 5 times, in fact, put it in brackets. There's 3 to the power of n minus 1. I've just expressed my series in a sigma notation. Of course, you can simplify further beyond what you're looking at here by changing 3 to the n minus 1 to 3 to the n and 3 to the 1 and writing it differently. But please, please, please don't multiply those bases. They're not the same. The exponents are not the same. Don't do that. All right, let's move on to the last one. The last question the examiner says we now need to calculate x. They say find x. That's what they're asking us. They say find the value of x. Okay, what is x? So if we go back to the stuff that was given to us, we clearly see that x is the sum. Because they're adding stuff there, guys. It's x is 5 plus 15 plus 45, all the way up to 20 terms. So x is basically the sum. So we are actually looking for the sum of a geometric form, or a geometric pattern. What is the formula for sum of a geometric? Sn is a into r to the n less 1 all over r minus 1, where r cannot be 1 because we know it's going to cause a lot of problems. It's going to be 1 minus 1, which is division by 0. If you do that, the world will end if you divide stuff by 0. Okay, what's term 1? Term 1 is 5. And then my ratio is 3. We're adding 20 terms less 1 all over 3 minus 1. Okay, this is going to be a very weird number because it's exponential. It grows really quick, guys. It grows really, really quick. So at this point, you go and fetch your calculator. Remember, a calculator is an instrument, not a monument. You guys should always make sure that you definitely use it, okay? So I'm going to call it fraction pattern. There's a fraction. On the numerator, I have 5 into, I've got 3 to the power of how many terms are we adding? We are summing up 20 terms. That's what the examiner said we have in this case, in this particular series. Minus 1 divided by 3 minus 1, which is simply 2. You can put 3 minus 1 because you guys simply don't trust yourselves. I've seen people doing 1 minus 1 with a calculator or 2 plus 1 with a calculator. So 3 minus 1 is 2. You can just do this and save time. It's a huge number. Very, very big number. 8,716,961,000. Okay, what's that? Million, I don't know. It's billions, I think. Okay, fine. So you can obviously even express it in exponential form. So it's 8,716, okay? And then if you come back, you'll get 961 with 3 zeros. The first 3 zeros is 1,000, then it's a million, then it's a billion. So we're looking at 8,716,961,000. That's the solution to this.